Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so without wasting much time, I'll be quickly moving on to our topic. We have been discussing about the measurement of length, and specifically in the last video we have discussed about how to measure length using a vernier calipers. Today we are going to talk about a different instrument, and it is basically about the screw gauge. So topic of our discussion today is a screw gauge. So let us see what is a screw gauge. So take out your pens and copies and make heading screw gauge. Okay. So basically what is a screw gauge? Now before discussing about screw gauge, I would like to discuss briefly about screw. Means actually the concept of screw gauge has been taken from the principle of working of a screw. So what is the principle of a screw? Okay, so do you know what is a screw? Yes, everybody must have seen a screw. Okay, isn't it? Now how can you define a screw? You have read this in previous classes that a screw is it's a device which has threads on it at equal distances along its length, isn't it? So screw is something which has threads. So it's something like this. If I draw the side view, it will look like something like this. Okay, like this. This is the head, and there are threads at equal distances, isn't it? So here are threads like this, isn't it? So this is the basic structure of a screw, isn't it? And what happens when you want, if you want to insert this screw into anything, what you have to do, you have to actually turn it round. Okay, if you turn it round in the clockwise direction, it will move into the rigid solid support in which you are trying to insert it, and if you move it anti-clockwise, it will just come out. Okay, so this is the basic concept of screw. Now, so this concept of screw is used in actually in a screw gauge. In a screw gauge, what is some similar technique is used in order to measure the length of very fine objects, say the diameter of a wire, okay, or the thickness of a coin. So like this kind of, when this kind of measurements has to be made, so we generally make use of a screw gauge. Okay, so now what is a screw gauge? But before talking about screw gauge or discussing the concept of screw gauge, let us briefly discuss about what is the pitch of a screw. So what is the pitch of a screw? I think this is a new term, so it is difficult to have an idea. So pitch of a screw is nothing but the linear distance that the screw moves, okay, when it is turned one complete rotation. Okay, so when you rotate the screw by one complete turn, the linear distance that it moves forward. See, if this is a screw and you are trying to move it round like this, okay, so see, when I turn it, you can see when I turn it and clockwise, you will be seeing it is anti-clockwise, it is going forward, and if I turn it back or turn it in the reverse direction, that is, you will see it clockwise, it is moving back. So one complete turn, so it is like this. If you just completely turn this like this, it will move a little bit in the forward direction. Okay, now this small distance that the screw moves in the forward direction or in the backward direction, when it is rotated one complete turn, is referred to as the pitch of the screw. Okay, so it's the distance moved along the axis. So by definition you can say that it is the distance, okay, moved along the axis, okay, distance moved along the axis, it is moving along the linear axis, is clear, along the axis of by the screw in one complete rotation. Okay, along the axis of the screw in one complete rotation. Okay, fine. So this is the concept of screw, isn't it? Yes, definitely. Now, so this is the basic concept of the pitch. Now, why we are talking this? Because we will be requiring these terms, so you have to know about these terms from the previous hand. Okay. Now, let us discuss another term which is called the least count. You have learned about least count when you are discussing about vernier calipers. Okay. So, least count is the least measurement that it can be made with the screw gauge or the screw. Okay. So, least count of a screw is the distance moved by along the axis by it in rotating the circular head by one division. Okay. So, when I want to say that I want to insert the screw, say the initially the screw is at this position of a wooden block. Okay. Now, if I want to insert the screw and say I want to insert up to this division. Okay, this division. So that is the least distance that I move it in the forward direction is the least count of the screw. Okay. So for the screw I can say that least count, how the least count is given by mathematically, how the least count is given by the pitch of the screw by the total number of divisions on the circular scale. So least count for a screw can be written as okay, so least count of a screw is equal to the pitch of the screw, okay, by the total number of divisions, okay, on the circular scale. Okay, on the circular scale. Fine, circular scale. So if I say here I have markings on this circular part. Okay, I am marking on the circular part. So I have a circular scale on this part here, say. Okay, number of divisions on the circular scale. Fine. So if I divisions like this on the circular scale, when you see the structure of the screw gauge, you will see that there are divisions like this on the circular. There is a circular scale on the screw. Okay. So if I want to rotate it, okay, I will be when I want to calculate this count, I will be seeing what is the pitch of the screw and what is the total number of divisions on the circular scale. That will give the least count of the screw. Okay, fine. Now we will be moving on to the actual construction of a screw gauge. So how does it look like? Okay. So if you are not noting these terms, please pause the video, move back a little, and if you want, you can copy the notations. Okay, or the terms. Fine. Okay. Now, then how is the structure of a screw gauge? It is something like this. Say there is a semicircular part like this. Okay, semicircular part. Semicircular part like this. Okay, and a screw like this turns up. Okay, a screw like this turns up. Okay, and for this to rotate, it is actually connected to a bit thicker part. Okay, thicker part. Fine. And here you have the circular scale. So here is the circular scale. Okay, like this, you have the circular scale here. Fine. Okay, and just continue with this part here. and to make it easy for rotation, there is another part here called the ratchet. Okay, the terms will be just discussing the terms little briefly, so that it's easier to understand. Okay, like this, something like that. Okay, fine. So this is the ratchet. Okay. So if I see, and this is the part, okay. So it will be, okay, here there is a small part here. The object that you want to measure is fitted into this gap, okay, this gap is fitted into this gap, fine. Okay, and here will be circular scale. Divisions here are present on the circular scale. Okay, fine. And this is the ratchet. Okay, this is the ratchet part. We twist the screw with by holding this part. Okay, by holding this part. See, if we move this part, this screw will go forward, isn't it? This screw will go forward, and it will give us the measurement. Okay, here on this part there is a linear scale attached. On this part we can see there is a linear scale attached. Okay, there is a linear scale, so it's marked here. There is a linear scale like this. Okay, fine. So as you move the screw, the linear scale also moves. Okay, so we get the linear distance. Okay, and then the circular circular distance is also measured, circular countings are also measured. So like this is the structure of a screw gauge. Okay, fine. So if I just see the structure, so this is the main screw, this is the U-shaped frame, this is the U-shaped frame. Okay, U frame. This is the stud, it holds the object here. Okay, STUD, stud. Okay, fine. And this is the ratchet, the end part is the ratchet. Okay, so this is the ratchet, RATCHET, ratchet. Okay, and anything else that you need to mention? And there is one main scale and there is one circular scale. Yes, these are the two things that you need to mention. This is the main scale. Let me mark it with green. This is the main scale. Okay, or linear scale, and this is the circular scale. Okay, this is the circular scale. Fine. Okay, so this is the main construction of the screw gauge. Okay, main construction of the screw gauge. Fine. So the construction is clear. Okay, now for when you want to measure any distance using the screw gauge, what you need to do, we need to first we need to calculate the least count of the screw gauge. So you know the least count of the screw gauge will be equal to pitch by number of circular divisions. This gives us the least count, as I have already seen. Okay, so least count is given by the pitch by number of circular divisions. Okay, then what you need to do, first of all we need to put the object in between the stud and the screw like this, and if we just move the screw by rotating the ratchet, this screw will move forward, and at a time it will just come forward, and say here an object is kept. Okay, consider a thin rod is kept here. Okay, a thin rod is kept here like this. Fine. If we just rotate this ratchet, the screw will move forward, and it will at one time it will just come and get attached onto this bar. Okay, get attached onto this bar. Fine. Like this it will be fine. Now here we will be able to see the linear distance that this main scale moves. Okay, and also while tightening, we will also see how much the circular scale moves. Okay, so you will get two reading. One is the main scale reading and one is the circular scale reading. Okay, so there will be two readings, and you have to add those two readings. Okay, but before moving to the calculation, here, as we have mentioned in case of vernier calipers, here also there is a concept of zero error, positive zero error and negative zero error. So what is zero error? If see actually if the zero of the circular scale is in line with the axis of the linear scale, okay, then it is said to be free from zero error. Okay, so if we just move the screw and it comes in contact with the stud, and you see the zero mark of the circular scale coincides with the baseline of the main scale. Okay, so see, if I just, there is no object here, and if I just move the ratchet and the screw comes forward and touches the stud, at that condition the zero of this main scale coincides with the axis of the linear scale. So this is the axis of the linear scale. Okay, so this is the axis of the linear scale. If the zero of the main circular scale coincides with the axis of the linear scale, then it is said to be free from zero error. But if it is not so, the zero of the circular scale does not match with the linear scale, then it is not free from zero error, it is set of zero error. Now what is positive zero error? If the zero of the so when zero error, when you can say that there is zero error if zero of circular scale does not coincide with baseline of main scale, then it is said to have zero error. Under what condition? When the screw is in contact with the stud. This is under the condition when screw is in contact with stud. So this is the condition when you actually can say that whether the screw guard is having a zero error or not. Okay, if it is not touching, then it may have positive zero error or negative zero error. So positive or negative both can be present. Okay, either one of these present. So when we set up positive zero error, if the zero of the circular scale is below the axis of the main scale, so if it is below the axis of main scale, and negative zero error if it is above the axis of main scale. So just like it like this briefly, it will be easier for you to memorize. Okay, if it is slightly above the main scale axis, then it is said to have negative zero error, and if it is below, then it is said to have positive zero error. Okay, so now when you have already obtained the zero error, then if we want to get the reading, what is the observed, then what is the reading? Then the reading can be taken as, the correct reading should be taken as observed reading minus the zero error with the proper sign. Now what is the value of the observed reading that you get? What is the value of the observed reading? So observed reading is obtained as, if we take the main scale reading, so I think you have copied these things. Okay, so how do you get the calculation? So what will be your observed reading? So your observed reading will be equal to main scale reading, okay, plus the circular scale reading multiplied by the what? Least count. Okay, so the number of, so it's the circular scale reading plus the circular scale reading multiplied by the least count. Okay, least count. So this is the observed reading, and the correct reading will be your observed reading minus the zero error with the proper sign. So your correct reading will be observed reading minus 0 error with proper sign. Okay, so this is the correction. So I think the concept of screw gauge is clear to all of you. So this is the main concept of the screw gauge. So in this way we can actually use the screw gauge to measure readings, okay, of very fine objects. So I think the concept of screw gauge is clear to all of you. Okay, so today we are ending our class here. There will be one more class regarding the chapter of measurement, and that will be regarding the measurement of time. So till the next video, please do study well, and if you have any query, please do mention in the comment box. We will be happy to solve your problem. Till the next video, please do study well. Thank you. Goodbye.